this third pre-lecture, we will start looking at some essential features of the C++ language. Something slightly more advanced and something much more like the object-oriented programming direction we are moving in towards. So the two features we're going to use today are some you've already seen, okay? But it may still be handy to deepen the understanding a little bit and to make sure that I do it in the most consistent way possible. So those two objects are strings, which are a way to store and manipulate groups of characters, and vectors, which provides with a mechanism to store and manipulate groups of numbers stored in a linear fashion. They're not necessarily numbers, though it could be any object, but at the moment we'll concentrate on numbers because those are often the more physical applications. We could easily have a vector of strings as well, which is definitely one example we'll see at some point. So, let's go over to discussing strings. A string, which essentially was this array of characters, is a vital feature of any programming language, and examples of its usage could be the names of files to read and write data from, parsing text, for example, if you want to count the number of words in a Shakespeare play, or in your lab reports, or if I want to do plagiarism checking, I need to have some understanding of what your text is made up from. Also, sometimes storing human-readable information. That could be in databases, but it could be in other places, names and addresses, degree courses, whatever. The title of your experiment if you have an electronic lab book. Historically, it was usually done by defining, using and manipulating arrays of characters. That's a bit awkward, but you may still meet codes that use this. The more modern way is put an abstract layer on top of that, where we don't mind what happens under the bonnet, but we do know exactly what happens. So the old-fashioned way is the array of characters, which I write down as the char square bracket opening at the top of this page. And to define a string in this way, you use an array of type characters. So suppose I declare an integer that has value 100. Then I define a string of length n, a fixed length string, or I can do it by declaring a pointer and allocating the pointer by doing a new of n characters, or I can even initialize a constant string, which is a slightly neater way of doing it, where you write a square bracket and write this is string 3, and that would store this is string 3 in that space you have over there. Now these character arrays are known for historical reasons as null terminated strings, a rather complicated term. Because what it really means, the way C++ is expected to store these character arrays, is that the last character, which is 1 byte long and is beyond what you can see on the page, is used for a so-called null character. So null character is just a 0, a character number 0, which we use to signify the end of string. They get added automatically, but you must have enough space for this extra character if you allocate an array, just to make things slightly more confusing. So you can really see that this is a very dangerous approach to take. Manipulation of character arrays is done via function calls. For this you need to include a C string library header at the top of the program, hash include sharp bracket C string close sharp bracket. To define string, you need to make use of the strcpy string copy function, and for the first two examples you could, for example, do string copy string 1, this is string 1, string copy string 2, this is string 2, so you now copy a string from string 1 to string 2. Character arrays can be inserted into cout as well, so you can just write cout string 1 and cout string 2, etc., and they get automatically outputted, so that's not too much of an imposition. Common functions to manipulate strings, and there's a few of them over here. You can compare two strings. You often want to know whether two strings are equal or not. And there's an strcmp string compare function which compares two strings, and it is a Boolean function which returns essentially false if they're not equal, so 0 if they're not equal, 1 if they're equal. And that's roughly all that happens. And you can base if statements on that as well. A very common process with strings is to join strings, which is called strictly concatenations of two strings. So for that reason, the function is called strcat, which string concatenates two strings and it adds the second string to the first. And if you do what we see over there, you could write down strcat string 1, string 2, so it joins string 1 and string 2 in that order. You can copy the strings with strcap. Second is copied to first, and you can also determine the length of the string by calling the function strlen on your object. Okay, that's all fair and good. Let's just look at the complete code and scroll through what we do. This just combines everything we've said. So we declare the strings like we did before, one string of length n, another string of length n by a pointer, or we define a string. We copy string, this is string 1 into string 1, this is string 2 into string 2. We then output all three strings to see what happens. We can compare string 1 and string 2. You can actually find whether they're equal or not. You can actually compare string 1 with itself, which better be equal, just to test it, and you find the strings are equal. You can glue string 2 after string 1, then you can copy string 1 to string 2 and see what happens to string 2, and then you can also calculate the length of string 2. So if you run this function, this is the output. You find this is string 1, 2, 3. Comparing string 1 and string 2, strings are not equal. Comparing string 1 with itself, strings are equal. Surprise. Join string, this is string 1, this is string 2. Now you copy, so that would be string 1 at that point. Now you copy string 1 to string 2, then string 2 changes of that as well. And you find the length of string 2 is actually 30. And there's no big surprise over there. So that all works fine and good. It's a bit inelegant and a bit messy, but it works. The alternative is the C++ standard library, which is done by using the string data type. And actually, string is actually not a data type, but as I say at the bottom of the page, it's a class, and we'll discuss classes in much more detail next week. I'll mention a little bit at the end of this lecture, pre-lecture today. String manipulation with string is easier and more powerful. You can grow or shrink when required, and do various other operations. So it's essentially not only an additional abstraction, it's also much more powerful, which you don't need to code stuff up, it's already in there. To start using strings, you need to include a header hash include string rather than hash include C-string. So we don't use C-string anymore. And then you can, for example, declare a string like that. I could have done it with curly brackets as well, which is probably should have done and changed it over here. And then you can output a string equally easy as you can output a C-string. The length is actually part of the function, and you see what I do is I have this function length acting on the object, or the function length that belongs to the object, and we'll discuss what that full stop over there means again in more detail a little bit later, but this is considered slightly more elegant syntax these days. We can also print out a character within the string, because you can deal with the strings almost like it was an array, which is good. So essentially you haven't lost that capability, and if you call it with the argument square bracket 1 close square bracket, which really means the second element, it will output the second element. Now, strings can also be defined from the input stream. There's no need to specify the length of the string in advance, which is a great advantage over the C string. So I can write down a string, input string, I say cout, enter a phrase, and C in input string. In this case I put a cin.ignore over there, which may well come in handy. We'll have to be a bit more careful about what we do with that today. But the first warning is that if it reads a string, it only extracts one word, as the input terminates at the first whitespace characters. Whitespace characters are typically things like spaces, tabs, and sometimes full stops as well. It leaves the rest of the text and potentially a new line as well in the buffer. And the new line is the reason that we need to put the cin.ignore over there. If you really want to read a whole sentence, you use the function getLine, which is also declared in the string header. So rather than using cin to something, we now say getLine cin input string, so it goes almost the same way. And again, you need the reason to use ignore, when you start muxing getLine and cin, things typically start going wrong, so you need to be really careful to ignore characters at the right places. Strings can be compared like other data types. For example, if I write down string my second string C++ rocks, I can just ask whether they equal. So that makes it much easier to make a comparison between two things than having to call a special function called strcmp as we did for the C strings. So, joining two strings is easy. We've defined the addition operator for strings as concatenations. So if you write down string, join string as my first string plus my second string, that's a join string. And you can also write my first string plus equals my second string, which appends second string to my first string. So it changes my first string by adding the words over there. So that's quite neat. You can also extract whole substrings rather than just characters by using a function called substr. Well, it's a bit short, but it just means substring. Arguments to substring are the position of the first character and optional the length of the substring. So it's slightly iffy counting stuff, as you can see below. For example, if I want to extract the characters from 18 to 22, and be careful, this really means from 90 to 23, because, right, we start counting at 0. No. So we do first to last minus first plus 1, and we need to check how that works. It might just be smart that you do a little bit of the testing and see how it goes. And the length, of course, is the last minus first plus 1, and that's clearly the correct length if I know the final position I want to go to. So I've done a bit of conversion over there as well. So let's look at the whole code. Once again, it's a reasonably long code, but it's all available on the interweb. So the string, my first string, hello world, you output it, you do the length of the string by calling the length of it, you look at the second character, then you input a phrase in two different ways. We do it both by doing the cin, which would just read a word, and we do it by using the get line, because they're both demonstrated over there. My second string is C++ rocks, and I can compare these two things, see whether it matches. I can actually also join strings together, I can append strings and see what happens, and finally I can extract parts from the code. So there's quite a few things I can do with strings. And if you really want to see, if you use this input, then essentially the second character in the string, well, you can work out why that's going to be an E, etc, etc. The phrase, okay, yeah, join string, hello world, C++ rocks, etc, etc. Try to convince yourself why this works, and if you extract stuff from this string, it was chosen so that the word rocks exactly comes out of it as the extracted string. Okay. Strikes me as being a reasonable approach. Final thing, which is really important, suppose you want to include non-string data in a string. For example, you want to include a number in a file because you're going to create 1,000 different files, and rather than giving them totally random names, you want to number them from 1 to 1,000 with some character identifiers before. So how do you do that? Well, C++ allows one to use something called string stream. So it mixes the idea of an input and an output stream with the idea of strings using something called string stream, S-stream over there. And for example, what I do in this small piece of code, I define an integer 1, 2, 3. I have an output file stream, an O string stream OFS. I write to output file stream file data dot, and I write down the file index. So this would generate a name file data.123 in the string data. In the string stream data, then I can extract the string from the string stream data by just calling str on this thing. And I could have done this all in one line. It's slightly neater to do it in 2 lines. It's hopefully slightly clearer to you what happens over there. So an output file stream has a little bit more around it than just the string information, but it does contain the string information, which we can get out of quite easily. We can also use this string function, this str function, to reset the string stream to make sure that we can clear the context. And once again, it's this appending of functions over there that's quite useful. So that's just what we've done. So I think we know about strings what we need to know. There's much more to know about strings, but essentially this is what we're going to need for this week. So let's continue to arrays and vectors. Almost any programming language has some kind of idea of what an array or a list is. They're often very similar, and essentially it's a list of numbers where there's easy way to access the numbers out of order. So it's a list where I don't need to walk through the whole list to get the numbers. I can just say I want the 10th element and it gets the 10th element. And we've already seen that before. You've all seen it before because I can declare a double of size 5 in this way, and then essentially I can fiddle with it, put some numbers in there and print out some values. And I hope that none of you would be staggeringly surprised that this code prints out the numbers 1, 2, 3, 4, 5. Would be a big surprise if it didn't. So that's perfectly fine. So why do we use other stuff? Well, C++ has something in there which they call vectors. And the name vector is slightly misleading. We'll come back to that in a minute. So I include again an extra header, a vector header and a string header. In this case, I do the same thing. I declare a vector of doubles which of length 5. So that's what I do over there. There's a reason not to put curly brackets around there because curly brackets would actually have initialized the thing. Now I really need to put round brackets about it because the meanings are different. I've got a vector double b, which defines an empty vector. I don't even know what it is. It just stores, I just tell you it stores doubles. I can make a vector of 3, 1. Actually, what that does, that statement does, it is a length 3 vector which contains 3 integers 1. Okay, that's quite a neat one. I can make a vector of strings, names. So you can have a vector with 3 strings, which clearly would hold names. Or I can make a vector of doubles, dd3. So D contains 3 empty double vectors. And I could, for example, set dd0 to A. And if you look what A is, A was a vector. So this sets the first element of dd to the vector A. So there's lots of weird stuff I'm doing over there. Now it's very important to understand a vector is much more like an array than what you call a vector in physics. So don't think it does exactly what a vector does. It doesn't know anything about normal vector algebra to that extent. I mean, there's other libraries that do more of that. Now, one of the reasons this is so useful, there's a number of library extensions, and I'll just mention 5 of the most important ones. The first one is empty, which is a Boolean function that tests whether a vector is empty, and all of these vectors act on an object of this type by putting a full stop and a name behind it. So it's .empty. If I do .size, I get the length of the vector. There's also .length, I think, which actually is the same as .size, to my big surprise. But the 2 most important features are pushback and popback. So this pushback adds an element at the end of the vector, so it extends the vector. And popback deletes the last element of the vector and shrinks it. So essentially these are very useful for vectors that are not of constant size. Remember the exercise you did last week where you read an amount of data? Well, with a vector it would have been really easy to just keep on pushing back, and it works that way. Now finally there's a statement called clear, which completely empties the content of a vector, so make it an empty vector so there's nothing stored in it anymore. Okay. Let's look at an example over here. So this example over here does various things. So it declares a vector of size 5. It initializes all the vectors like I showed before. I showed you everything up to here. It then says if not a.empty. If a is not empty, then a is not empty. Yep. If b is empty, then you output b is empty. Then you output the sizes of 3 of these vectors. You also output the size of names and the size of DDs. I then initialize names of 0, names of 1, names of 2 to vector of strings, and then I can actually run over the size of the vector by doing a cout. Okay, this should have been indented, and I don't know why it's not indented, but that's not an apparently good reason. And I then can push back some numbers on B and output the size of B, and I can output all the sizes and all the detail inside the function. So that all looks pretty cool and pretty clear. So this is reasonably powerful ways of using a vector in all kinds of contexts. And if you look at the output, if you want to see what happens, then it shouldn't be surprised you if you thought a little bit about it, that essentially at the end B is empty and initially A was not empty. And you can check the other outputs in between and compare it to your own favorite compiler and see whether it does the same thing as the compiler I've run this with. Okay, so a very important piece of technology is something called an iterator. So I want to emphasize it a little bit, and iterators will be emphasized over and over again because they're a rather peculiar feature of C++. It's the idea of having the same way to run through any of the data structures in the standard library. So any, not only vectors, any of the extended data structures, you can walk through them element by element by using an iterator, which means I won't have to change this code if I turn the vector into a dictionary or something else like that, which is a different way of storing data, or a queue or a list or whatever. So what I can do in this main vector, and so this is exactly the same I've done before, declare a vector of doubles b, add 3 numbers to the vector, so now it's a vector of length 3, and then I declare something called an iterator. Well, I declare 2 iterators. One of them is double begin, which is b.begin. The other one is double.end, which is b.end. So these are the beginning and the end of my array b, functions I haven't defined before. And now I have a type, or I declare a third iterator, which is the one I use to iterate through my data, which is called double current. And double current starts at double begin, double current must be less than double end, and I increment double current. I don't even know what the increments are because it depends on how this stuff is stored. So no, I don't need to know anything about how the data is stored, it just works automatically. But in order to get the element pointed at by double current, I need to dereference it. So double current acts very much like a pointer. So this is a type of generic programming where using pointer-like objects called iterators. Iterators are not pointers, but they're very similar to pointers, is incredibly helpful. So they seem a bit more cumbersome, but they apply more widely. And more importantly, they are used in some useful functions. And let me show you some functions which are already quite handy as well. For example, I want to sort a set of data, and I want to reverse the order of every element in a vector. Both of those look quite useful. There's yet another header we can use called algorithm. And there's a lot more in algorithm than I do here, but algorithm definitely contains sort and reverse, and that sort and reverse would then again be defined for many different types of objects, but definitely for vectors. So I go for the same story, my vector b, add 3 elements to my vector b, I declare the iterators for begin and end, and I can then sort from the iterator that points to the begin to the iterator that points at the end. That would then, so this changes the data. And it will then, if I output in the same way as it did before, I can output my data, and you'll notice if you do run this code carefully that indeed the data is sorted. Initially it was 4.5, 1.5, 3, so that's clearly not sorted. 1.5, 3, 4.5 is the output I get if I do that. Then if I reverse the sorted data, what I then need to do is, let's look at it carefully, what I just call the function reverse with the same arguments, but of course I haven't done anything to this, and what it now does is get 4.5, 3, 1.5 if you print it out. So just an idea why iterators are going to be so powerful, so useful, because it's a generic statement. It doesn't need to know much about what the class is. I can use the same function on it. Now, I've already used the words quite a bit in talking to you, but you may already have guessed, or you may know, I hope some of you may know, that vectors and strings are examples of what C++ called an object. And we met some objects before. Cout and cin and file streams are objects as well. Objects are made from elements, from 2 elements, and there should be a W in there. Data and their organization, the operators that can be performed on the objects. For example, if you want to calculate the size of the vector, that clearly is also part of the things that go around an object. So the rules are collected in an object called the class, And vectors and strings are two predefined classes as part of the C++ standard library. Actually, the vector class is part of the standard template library, which also include lists, sets, and maps. And in the next lecture, you will learn how to write your own classes.